Hey everyone, this is Ken. In this video, I'm going to show you a formula for the sum of the first n numbers. So in a previous video, we introduced summation notation, and I had looked at this sum of I, for I goes from 1 to n. This is, of course, equal to 1 plus 2 plus 3 all the way up to n. And the question is there a formula for this? Is there a nice, easy formula that I can input the number n, like how many numbers do I want to add together, and output what's the value? So for instance, say I wanted to add the first 100 numbers together, what would the answer be? Can I do that really quickly without having to actually perform 100 additions? And there's a nice way to do this that there's a story that it's due to the mathematician Carl Friedrich Gauss. I don't know if this is apocryphal or not, but the story is that when he was very young, like 6 or 7, in one of the early grades, he was in class, okay? And so he was like a very precocious student, not so good at paying attention or following the rules, and like very good at math. So to punish him, the teacher said, okay, go sit in the corner and take your slate and add up all the numbers from 1 to 100, and then don't come back until you are finished. And so he goes over to the corner, and the teacher continues class, and about 30 seconds later, Gauss has written the answer, whatever it is, 5050, on the slate, and he throws it at his teacher's feet and says, there lies your answer. And we're told that the teacher then sort of got upset and beat him. Okay, but then the teacher went home and added all the numbers together and figured out that actually Gauss was right, and then came back later and said, well, actually this person's really talented, then sent him away to get some better study, and then the rest is history. Gauss became one of the most famous mathematicians of his time, and basically invented the field of differential geometry, which I study. So who knows if that's true or not, but maybe some version of it is. But I'm going to show you the process that is credited to this very small child. And it's really astounding. So here's the idea. So say you want to calculate this value. Well, whatever the value is, it certainly exists. It's equal to something. So let's add it to itself. I'll write it out again. But this time I'll write it in reverse order. N plus n minus 1 plus n minus 2, all the way down to 1. And when you add those things together, you're going to end up with, well, first of all, you're going to get twice the sum. And second of all, you're going to get 1 plus n. So n plus 1. You're going to get 2 plus n minus 1. It's n plus 1. You're going to get 3 plus n minus 2. N plus 1. They all add up to n plus 1. And you keep on going. And finally, still n plus 1 is n plus 1. And so you look at how many times you've added n plus 1 together. There's n terms in this sum, of course, so you added them together n times. So what you've done is you have found that twice the sum is equal to n times n plus 1. And now just dividing by 2 on both sides, you're going to get that the sum of the first n numbers is nothing but n times n plus 1 over 2. So you go back to this problem where the teacher said, like, hey, add up all the numbers from 1 to 100. Then you know the answer is just going to be 100 times 101 over 2. So you can quickly calculate that out. So 101 multiplied by 100 is 10,100 divided by 2, and you end up with 5,050 And you can get that answer in just a couple of seconds. You didn't actually need to do all of it. So that's really great. In another video, I'll put this to work and actually use it to help us calculate an integral, a definite integral, straight from the definition. There's other formulas that are useful. You can also ask yourself, what's the sum of the first n squares? What's the sum of the first n cubes? There's other formulas that are like that. You can Google them. They're in your textbook. I won't talk about them here. You can prove them all with a technique called mathematical induction. I don't know if there's something so simple that could prove like the sum of the squares is equal to its formula, but I challenge you to check that out and see if maybe you can find something. So there you have it.